Hey guys, happy Tuesday. Okay, so today we're going to continue with applications of quadratics, and we're going to do this little like task card activity. You do have a test on Thursday. Do not forget that. And real important to get that done before we leave for spring break. So on the test, I'll post a review tomorrow, and you'll get to see the types of problems that'll be on the test. It'll be things like we're on the project, domain and range, and then like these task card questions here. Okay, so today in Canvas, this is the assignment that I'm talking about here. I'm gonna actually, oh look, let's me view it. No, it doesn't. I thought it was calling me view it in student view. Okay, so it looks like this, except, goodness, you guys have a submit button over here. So here's what I would do. See this little pop out arrow right here? I would click that, and then you can have the cards open in one window. So there's your questions. But your answers, you're going to log down here. So I would click this blue link right here, and then it'll open those in a new window. Okay, so here's the questions. They're called task 1, 2, 3. And then there's A, B, C for each one of them. Yeah, there's 10 of them, okay? So I'm probably going to work like problems 1 and 2 with you. And then what you're going to do is come over here and you're going to put your answers over here. You're going to type your answers in the yellow boxes. And this is one of those, it'll turn green if you have it correct. So it's nice because you know if you get it correct or not. You are going to need Desmos, so make sure you open up Desmos in another window. And remember, you can always find Desmos. Well, I'm not in student view here. Let me go to student view really quick. This is what yours looks like. Desmos is down here in my Canvas. I'm going to link there. Okay, so task 1, your nephew, standing on his deck, which is 4 feet off the ground, and he tosses his toy up into the air with an initial velocity of 7 feet per second. Again, when they tell you information like this, they're telling you where the parts of this equation came from. That's where the 7 came from. Here's your equation that models a toy's height in feet from the ground at t seconds after he threw it. Okay, so I'm going to type this equation in Desmos. Desmos is going to be like super important. H of t equals -2. So I'm going to type it. Now this is function notation again. When we have these parentheses, remember all it's telling you is this is in fact a function. If they're using function notation with the h of t, or sometimes they use f of x or g of x, that's just telling you this is indeed a function and our input is t. So that stands for time, right? -2t squared plus 7t plus 4. I've got my equation typed in. Now I can't see it because I think my zoom is off. So what I'm going to do is if I hit the home screen, it usually brings it up. Okay, so here it is. Here's a model of it. And remember, guys, normally we're just looking at this positive quadrant here, quadrant 1. So right here, remember t, or your x, your input stands for time, and then y is going to be your height. That's h. That's where we normally have y. So at the very beginning here, at the y-intercept, notice that's where it's crossing the y-axis. At time of 0, how high is the toy off the ground? What's my height? Because remember, y is height. So x is time, y is height. Every point that you click on, that's what you need to think. So I've got some points over here. Now I've got another one over here I could click on. But let's look at this one. Here's why we don't usually use this. So if x is time, it doesn't make sense for me to think of -0.5 seconds. No, it doesn't. We don't talk about negative time. So these are applications. This is how they apply in real life. So I don't need to look at negative x values over here. So that's why I don't even need this point. Here's my toy at 0 seconds. He was 4 feet off the ground. He threw it up into the air, and then it came down and it hit the ground. And I know it's on the ground because what's my height here? 0. My y value is 0 here. So that means the toy is 0 feet off the ground. Yeah, that makes sense. If you're on the ground, how high are you off the ground? You have a height of 0. There's no height there. Okay, so the first one's asking me, how high is the toy after 1 second? Well, that's a time of 1. So I could go and try to start tracing my curve here and get to 1. And I'm seeing up here at 1.75, this is how high it is. But that can be really hard in Desmos because it's real finicky and it doesn't always want to land straight on. Oh, I did it. It happened to land straight on 1. So you could do that, or you could kind of try to estimate. Okay, up here at 1, what is it? Well, it's in between 8 and 10. That looks like 9. But you also could come over here because remember, this is function notation. This is telling you time is input. And they're saying, hey, I have an input of 1 second. So I could ask Desmos, oh, okay, so if I input 1, what's my output? Input is time, output is height. Oh, 9. So then I'll come over to my answer sheet and go, well, for number 1, I think it's 9. And you have to click it and then hit enter because it's not going to turn green until you either click out of that cell or hit enter. So I got that one correct. Okay, B says, what is the toy's maximum height? Okay, well, the maximum, I see it was thrown up all the way up to here, and then it started coming back down and hit the ground. So its maximum height, now is it the 1.75 or the 10.125? So that's what you have to remember. And you have to think, okay, but X is my time. So that's the time at 1.75 seconds. Oh, it was 10 feet off the ground, 10.125. Now, I'm pretty sure somewhere in here it said, no, it doesn't. Oh, it's on the thing. So you can round your answer if you want to a couple of decimal places, or you could just put the 10.125 in. It should say it's right either way. So its maximum height was about 10 feet off the ground. Okay, how long is the toy in the air? Okay, well, look, here's where it started because your nephew's on the deck. Throws it up, and then it comes down and hits the ground, right? So this is the total time it was in the air. You don't have to estimate this. The point is going to tell you. So remember, if it's no longer if I want to know how long it was in the air, that's when it went up and then hit the ground. Boom. So when it's on the ground, it's finished its flight. But how long did that take? Because remember, X, your X value here is your time that it took to get to 0 feet off the ground. Oh, well, it took 4 seconds. So that must be how long it was in the air for. A total of 4 seconds. Boom. Got it right. Okay. So let me work another one for you. So here's a squirrel. He jumped from a tree that's 11 feet in the air at an initial velocity of 9 feet per second. Here's your equation, models his jump, where h is the height in feet and t is the time in seconds. What was the squirrel's maximum height? Okay, so I'm going to go back to Desmos. You're going to be using Desmos on all of these. H of t is negative 2t squared. Okay, I've already got that typed in. Plus 9t plus 11. So here we go. So this one's really similar. So let's zoom out. So here's my squirrel. He's like on a tree or something, right? Here, boom, he jumps up in the air, boom, and then he comes down and he hits the ground, boom. So the first question says, what is his maximum height? Well, we can see that. He jumped all the way up to here. Then you have to be careful. Is it the 2.25 or the 21.125? Which one is the maximum height? This are the coordinates of the maximum. But when they're talking about the height, oh, well, that's where y would normally be. That's your y value. So, and usually it's the bigger number. And usually your x value is your time. So he's 2.25 seconds is how long it took him to actually get to his maximum height, which is the 21.125. So again, you can round this if you want, or you don't have to. It should take it both ways. How many seconds after he jumped was the squirrel at his highest point? Okay, that's what we just talked about. So how many seconds? So at 0 seconds, he hasn't jumped yet. It's like he jumped and someone started a stopwatch. So he hasn't jumped yet. Nobody starts a stopwatch. He's at his 11 feet in his tree or whatever. Then he jumps up. Well, the time there at his maximum is the 2.25. And then what's the last question? When did the squirrel reach the ground? So notice they said when. They didn't say what's the height when he reached the ground. But we know he's on the ground when his height is 0. So that's over here, boom. So your x-axis represents the ground, or it could represent the surface of the water. So sometimes you can go negative, because if you're talking about like this is the surface of the water, well, this is above the water, and then when you go below, it could be below the water. But since this is talking about the ground, we don't jump and go below ground, right? That would probably be dead if we made an addition in the ground. So he stops on the ground. He lands on his feet because squirrels are nimble little creatures. And at 0 feet off the ground, so he's touching the ground. It took him 5.5 seconds. So when did he reach the ground? Well, 5.5 seconds. That's a long flight for a little squirrel. There we go. Okay, so this is kind of how you're going to have to work through these problems. You're going to use Desmos. There's really no work on paper. It's really graphing your equation in Desmos and then letting Desmos help you and kind of imagining the flight or the path of whatever the object is and then looking at those key features, the same key features we were looking at when we were doing your quadratics project, but now we're interpreting them in a real life situation.